must have been fortuitous. I forgot my glasses, so I was going to kind of use this as a cheat sheet. So I guess I'm supposed to just kind of go off of That's not good. Maybe it's all those horses you have.
Off the cuff.
That's what it is.
On the hoof.
It's all those horses she has that got me there. Okay, I'm really pleased to introduce Cindy Schellenberg and to you, and thanks for coming all the way from Sonoma.
Wow.
Whoa. Yeah. She came in last night and stayed with us overnight, so I got to know her a little bit. And she's in heavy commute traffic, by the way. She had a very tough road to hold there. 3 hours did it take you to get here? Oh, yeah.
Thank you for being perseverant.
Yeah, thank you.
So Cindy was in the corporate world for quite a while. For 35 years, she was in corporate finance and with some really big names in that world, like Wells Fargo and GMEC. And then she found, and she now lives in Sonoma, where she has a big ranch of horses and cows. Oh, do you have cows? I don't know. But you have chickens and goats.
She has 5 horses.
5 horses.
Wow.
And cats and dogs, and last but not least, a granddaughter and a daughter. And then she has 42 little chickens. which she takes under her wing, and that's 3 of us are here, Beamer distributors. She was lucky enough to discover Beamer 12 years ago, before it was even here in the United States. And 7 years ago is when she really got into the business of it. And now she's in charge of 42 distributors, which is really amazing. It's a full-time job. So today she's not going to talk to us so much about Beamer, but about what your blood is going to do, optimal blood flow and how that is important to your health. So I'd like you to join me in welcoming Cindy here.
And thank you to my gracious hosts, Joyce and Davey, for giving me a place to stay and inviting me to join you here today, because the future of our planet depends upon these kinds of connections. And I appreciate the energy that I feel from you. And I'm glad to share what I have today. Now, this is going to take me, I've got to sit up here for a few minutes, so. This guy. This is the kind of line it up.
Why don't you begin without your assistant?
Well, what I wanted to talk about today, and what I said in my preface that you shared before, is why we say that microcirculation is the key to health. There's a lot of things that our amazing body does every day that we take for granted. We're not conscious about breathing. We're not conscious about our body controlling the temperature. There's a number of things. Should I turn this one off too? Sure. Where did I turn it here? There? Okay. Yeah, that's better. So we like to be able to share with people some things that have come about in scientific research, really certainly since I was in school, and perhaps you as well, because with the age of technology, we're now able to see and understand things at a much, much tinier level. And so it is no secret that, yes, I am involved with Beamer, but I do want to, there's one thing that, even though I'm not going to talk about that directly, what I do need to read to you is this disclaimer. And it's because I borrowed some slides from Beamer. I made a special presentation for you so that you wouldn't say it was a sales presentation. Because it's not, it's an education. I believe this is a gift of information to share with you. But this disclaimer is necessary for our stage as a company in getting FDA approval. And basically, it's telling you that anything to do with BEMER is not a substitute for professional medical care, that BEMER is a wellness and fitness system. And I won't read the whole thing for you, but I want to put that up there just because I might slip and say the word BEMER a couple of times.
It's okay,
It's
fine, no worries, okay?
So, anyway, I wanted to start that out. So, when we're talking about microcirculation, that's a terminology that many people are not familiar with, but there's some other things. Have you ever heard of something called intravital microscopy? It's kind of a mouthful.
No.
And so that's one of the new technologies that's so amazing, and you're seeing a still shot of that right here. It's a picture that is showing at a very microscopic level one of the parts of the body, blood flow. And we'll see a few that are moving later, but intravital microscopy. Our microvessels are made up of capillaries and arterioles and venules. Different words you might not have heard of. There's another concept called vasomotion. And we're going to talk about a little bit about something called ATP, otherwise affectionately known as adenosine triphosphate. And then just some of our regulatory systems, because our body is made up of so many systems that interact, and they have different frequencies, but they all function on energy. So some of this terminology may be unfamiliar to you, but I just wanted to say up front, hopefully I will be able to explain it so you understand. So I think an interesting way to start is to ask people if you say, are we healthy today, particularly in our society? I think the general consensus would be no, and I really love this quote, because during the first part of our life we sacrifice health in order to gain money. And then in the next part of our life we sacrifice, or we give back the money in order to regain the health that we lost. So now, do you have an idea? This is an actual direct quotation from someone. Do you have an idea of who might have said that?
The Dalai Lama?
That would be a good
He
guess.
said something very similar.
Dyer.
He does.
Wayne Dyer?
And Andrew Weil, all of those would be great guesses, but this was said by Voltaire in the 18th century.
Oh my God.
So we've had this problem for a long time. The idea is to say, it's time to shift the paradigm.
Yes.
Okay. So if we look today in our industrialized society, and I know this is hard to see a little bit for you, but there's more than 45,000 known medical conditions, chronic conditions and diseases. 45,000, and that number's on the rise. 1 in every 3 Americans takes medication for chronic pain. The cause of many of these conditions is found in what we say is disturbed or impaired microcirculation. And every day there are 6,000 new patients that are diagnosed with vascular diseases. This is really a catastrophic thing that we're not very well aware of. We estimate that about between 90 and 95% of the conditions and diseases today have a root cause in lack of proper circulation. So, can anybody tell me what the major cause of death is in this country?
Heart disease?
Heart disease, absolutely. Heart failure, which is a circulatory disease. What about the second?
Cancer?
The second would be cancer, but what's racing to catch up with it? What's the third major?
Stroke? Diabetes?
Diabetes. Well, certainly it's an epidemic stage, but no, the third major cause of death is incompatible prescriptions or drug, and it's approaching the second.
I was going to say doctors and hospitals.
Yeah, so it's all wrapped up there, and I don't have anything to disparage the medical profession, but I mean, we are controlled, certainly, not controlled, but certainly influenced heavily by Big Pharma. So this is what I would call a stage of massive alert in our society today. Here's another way of looking if you have grandchildren. The new childhood in America, 1 in 3 overweight, 1 in 6 learning disabilities, asthma, ADHD, food allergies, seizures, autism. This is the life our children are leading. And the point is, 50% of all children have chronic illness or overweight. And certainly, the more that they sit and play video games and text and watch TV, it's not helping. So we really have a crisis situation in this country, and it's really time to pay attention. So, attention deficit disorder. So if you take a look at the fact that our lifestyle today is what I would call conducive to promoting disease. The first one is that we don't move enough. We move an average of half a mile a day at most. We spend a lot of time sitting and talking and being at a computer or driving. We have shallow and rapid breathing. You know, it was very nice to begin the day with deep breaths, and we know how valuable that is. It's a basic thing, but we don't do it much. When you get wrapped up, you don't breathe properly. We get stress from multiple sources, and you know, from personal experience, is when it's stressful, you tend to breathe much more shallow. One of the things also we know about stress is that it constricts your blood flow. It also causes the production of free radicals and cortisol, which are very harmful. So our bodies are designed to cope with stress, like to run up a tree when a tiger's chasing us, but it's not designed for protracted stress. And that's what we're, you know, whether it's traffic jams or can't pay the bills or taxes are due or marital issues, whatever it is, we live in an environment where the stress is prolonged. Malnutrition, from the fact that we still have fast foods and McDonald's and Burger King that people exclusively eat. You've got to be, I'm sure many of you are aware that you have to be a massive label reader to know what it is you're putting in, and if you don't make it yourself, you really don't know what you're getting. And the fact even that our ability to be organic is not as much as, it's not as pristine as it used to be. It's just a fact of life. We're surrounded by environmental toxins, diesel fumes, cell phone, microwaves. It's all around us and invisible, and it's taking a toll on our body. So those kinds of things, including the incompatibility of medications and the fact that we take way too many. I worked some time at a senior center, and in Petaluma had asked people to just tell me what medications you're taking, and they bring in a supermarket bag full because there's so many they don't even know what they are. And I can absolutely bet that whatever doctors are seeing have no idea that they're taking all of those things either. So the combination of these kinds of strong influences means that there is in our bodies a deficiency of energy and oxygen. And that's where disease starts. It starts at a very basic level. So we don't often think of the fact that we talk here today about energy, but we don't even think about the fact that we're electrical energy production machines, if you will. That's how our cells, between chemical processes and interactions and energetic ones electrically, that's how our body communicates. And every single function within our body relies on this energy. And what's really interesting, one of the things I love to find out about is like different organs and different parts of your body, they vibrate, they have a different frequency. So that's how they know how to communicate that a liver cell can talk to other liver cells, not to a cell that's in your brain or something. So very interesting how the body is constructed. And I love to share this slide because if you were to count them, you can see maybe the 21, and there are 21 zeros there.
Wow.
Whoa.
And that's a big number, so that's why I had to put it up there, because that's sextillion. If I had said sextillion, you wouldn't have had a visual for what that is. But that's, I got it. And it's coming now. Well, thank goodness for computers, or we wouldn't know those numbers, yeah? But that's 21 sextillion chemical reactions every single second in your body. Every single second that's going on.
Wow.
This one down here is quadrillion, and that's protein degradations and regenerations every second. Again, that's how we function all the time. That's what our body needs.
What does that mean, protein regeneration?
Degradations,
What
that
does that mean?
changes, is that they're converting into something else.
Oh.
And
food into.
It's just, it's a synthesis process.
I was wondering why all these conversations were going on.
There's a lot of them for sure. So let's take a look just at an individual cell, because the smallest form of life in our body, self-contained, is an individual cell. And that's kind of this picture here. And so what you see, there's a nucleus, the blue one in the center, and then the little yellow like Easter eggs here are mitochondria. And that's what spins around to create the energy. That's the ATP in the center. But what's very interesting, if you see that at the edge of this cell, it has like a skin or a membrane, and it's darker. And you see the plus and the minus. Every cell has an electrical charge to it. And it's called the cellular membrane voltage potential. And it is supposed to be in a very finite, tiny range of minus 70 to minus 90 millivolts. That doesn't mean much to you other than to say, gosh, that's a very microscopic level. And that range is very finite. In order for that charge around every cell to be in that range, it allows oxygen to enter. It makes the cell wall is permeable to allow oxygen to come in, and it allows all the nutrients in. It also allows the exit of carbon dioxide and water that carries all of the toxins and waste products out of the cell. So that membrane has to be permeable, and it has to stay in that range of minus 70, minus 90 millivolts. When it's not, when it's at a lower level, the cell starts to collapse. When it starts to collapse, then it becomes less permeable. So not only are you not getting nutrients and oxygen in, you're trapping all the waste products inside. They're not able to get out. It's the same premise as when you say you don't take garbage out, you know what happens. So in order for the cells to make their own energy, and almost every cell in our body makes its own energy, it has to have oxygen. It's the key to making energy. And keep that in mind as we go on and talk a little bit more, because that makes just a huge difference. So I can show you a different picture that's really interesting. If any of you have ever gone to a practitioner who does dark field microscopy, it's a live blood analysis. And this is how I first encountered my doctor, who's also the person who introduced me to and but she does this in her office, and I was so impressed because I went, oh my gosh, it's my blood on the microscope, you know, right in front of me, and we're interpreting what's happening in my body, not some class of certain age of women.
Yeah, wow.
And so I really appreciated that. What you see on the left is what most people's blood looks like today. These are red blood cells, and they're clumped together. And one of the reasons that they're clumped together is because they don't have enough energy. That membrane voltage potential, that skin around each cell is not in the right range. So when it isn't, they tend to collapse. And then what they also do is they stick together. Now, this is what you want your blood to look more like. And you notice the change. You see there's actually the red blood cells are rounder looking. If you've ever heard about the Chinese concept of saying energy between the cells, this is what Chinese would call sticky blood. So the job of, do you know what the job of a red blood cell is in the body?
No.
Well, what a red blood cell does is it's a carrier. It carries oxygen in and it carries CO2 out. And the way it does that is it has little protein markers on the outside of the cell. There's 4 of them. They're docking stations that grab the molecules to attach. Now, if the red blood cell doesn't have enough energy itself, how many others, if they're supposed to each attach 4 molecules, do you think they can attach very much in this stage when they're clumped together? They can't do anything. They can maybe attach them 1 or 2. So all of a sudden, they're not able to do their job when they don't have enough energy. And it's a downward spiral. less energy, less oxygen in makes less energy. So when they're clumped together like that, they can't do their job, and additionally, they're not able to get into your tiniest blood vessels, which are about, they run down in size to maybe 10 times smaller than a human hair. So for a red blood cell to get into your tiniest blood vessels, it has to squeeze and constrict itself to even get in. This is kind of like a Drano clog, if you will. And what you want your blood to look like is this. I will tell you that the difference in these two pictures is after 8 minutes on a certain piece of equipment. So let's look at
Oh, the beamer.
You can say
okay, you
can
say. I know, but I'm adhering to the rules. So I can do questions at the end if you don't mind. So let's take a look at, remember one of our words was intravital microscopy? This is what intravital microscopy looks like in a still form. And this is tiny, tiny capillaries around here. This is a slightly larger vessel, which is called an arterial, which is a smaller artery, if you will. And you can see here, there's kind of little circles. Those are individual red blood cells kind of moving along. And I'm going to animate it here in a minute. But I just wanted, you tell me, it'll be a difference of several minutes here. But when we talk about circulation not working, we tend to think, oh, that's probably something that happens as we get older. And that may be true, but it is not limited to people of any certain age. What we're going to look at is, comes from looking at a young man. He's 26 years old. He's not a professional athlete, but he exercises all the time and he's in really good shape. He just went into a doctor for a physical. He feels fine. He went through the physical. Doctor said, you're great. Then they hooked him up to be able to look at, literally at a microscopic level, what was going on with his blood. So you'll see how, what it looks like at first. Is this moving very fast here?
No.
No.
And there's a, that means all this tissue around here, not much is getting distributed to it. It's pretty, this is kind of like the traffic I was in. Tell me if you see a difference.
It's going faster.
That's 2 minutes later.
Oh my God.
Wow.
Did they speed up
On
the
that
film or is
certain
that
piece of
the?
equipment.
On that piece of equipment. So this just gives you a little feeling for the difference, again, before and a little bit later. Pretty dramatic to see these pictures. So, if we take a look, when we think about our circulatory system, we think, everybody kind of recognizes that we have a heart. And the heart is only about the size of your fist. It's not very big. And
On the block cells, are they dead or do they just need more energy to?
they're not dead, they're just compromised. So, yeah, they need more energy. So, again, when we look at the heart, we have about 5 or 6 gallons of blood in our body, but the heart has to pump the equivalent of about 2,000 gallons of blood through our system every day. And if you were in a laboratory and you were trying to create a piece of equipment to pump as much blood as the heart has to all through the body, would you be able to do that with just this one single pump? No. The heart cannot. The answer to that question is, can the heart do it by itself? No, it can't. And this is what's so beautiful about the body. One of the things that's been found is the body has a natural function, and it's called vasomotion. That was one of the words in our terminology. And that is a specific kind of cardiac assistance. And what that means is, as your arteries and veins get smaller and smaller, we call them arterioles and venules, and then they get smaller and smaller and turn into capillaries. Bless you. But those medium-sized blood vessels, the ones I call arterioles on the artery side, or venules on the vein side, they have a function that allows them, they have muscles in the walls of the vessels, and they expand and contract. And what does that function produce? It makes a pumping action, it raises pressure. And what does that do? It pushes the blood into the tiniest vessels. The heart was absolutely designed to have this kind of assistance working for it, because it can't do it all by itself. Now, if you're talking about a young and healthy person, it would happen, that pumping action would maybe happen 3 to 5 times a minute. We said here 30 to 50 times in 10 minutes. So it's pretty regular. As we get older, or in any way our health is compromised, and we used in this example, we used someone who was diabetic, because that's the circulatory disease poster child. It might happen once in 10 minutes. So if your heart needs this to happen 3 to 5 times a minute, and it happens once in 10 minutes, where's all of the stress being, what organ is being?
The heart, well, everything.
The whole.
The whole everything, but particularly your heart. And it is not coincidental that heart disease and heart failure are the #1 cause of death in this country. It's because this isn't happening. Okay, and we'll talk about why that's, again, why that's so important. So I want to show you a picture, again, using intravital microscopy. I can show you from our laboratory, not our laboratory, but an institute laboratory in Berlin, what this vasomotion pumping action looks like. So this is in real time. Watch the width of these vessels over time. And you'll see them getting narrower and narrower. You'll also get to see something really fun. You'll get to see the blood change direction, which is very cool.
So,
Why is it
Yes.
shrinking?
Because that's the pumping action. It gets smaller and
Oh.
bigger. Small.
Does cholesterol really affect that?
Let me answer that later, okay, if you wouldn't mind. Did you just see the blood change direction here?
Mm-hmm.
That's another aspect of vasomotion, because we don't have enough blood to be everywhere in our body at one time. So your body has a system which says, okay, if you're eating, I'm going to move blood into your gut or your intestines. If you're running, I'm going to move it to your musculoskeletal system. So again, this was in real time. This is one of the 3 to 5 times in a minute of what this vasomotion happens. And your body is constantly redirecting where the blood will go. And
there's some bugs on it.
yeah.
Cindy, isn't that why they used to tell us, after you eat, don't go swimming? I used to hear that
Well, sure,
because.
that's one of the things. Yeah, you need time
Yeah.
to be able to absolutely digest your food.
Yeah.
So I think, anyway, these pictures, and I will tell you that there's very few people in the world that have seen pictures like this, because there's only a handful of laboratories that are able to produce these kinds of photographs. And again, this comes from really expensive equipment in an independent lab in Berlin that we were very lucky to hook up with.